I welcome everyone to the lecture series on control systems. In this lecture series, we are going to see the modeling of electrical and mechanical systems, then signal flow graph, block diagram reductions, time domain specifications, frequency domain specifications, stability analysis, and finally, we are going to conclude it with compensator designs. Okay, if you have any doubt, you can just refer the books which is shown here, that is Control System Engineering by Nagarathan Gopal and Control Systems by Nagur King. First of all, before going into various topics of control systems, we need to know about control system. Okay, the purpose and application of it. So before entering into the topic, I would tell that our human body is the best example of a control system. It is an intelligent control system. How I am saying that? We everyone know that whatever the thing which is happening in our body will be having a reverse operation in order to make it perfect. Okay, so we know that control system is mainly used to get an desired thing. So whenever we fall sick, something is being created in our body which makes us which makes our body to immune and affect our thing, and we used to come out of that. Okay, so it is an intelligent control system. Okay, and there are various parts which are being driven by the brain. So brain is the masterpiece here, which used to command each and every part with the help of the signals. Okay, it acts as a controller here. It acts as a controller here. So here sensors are ear, nose, eyes are the sensors which used to collect the data and which used to give the data to the brain, and brain used to execute the process, and whenever there is a necessary, it used to actuates various parts in order to get an desired output. Okay, so purpose of control system in human is to perform the task as desired and initiated by the brain. As I mentioned earlier, our human body is the perfect control system, that is intelligent control system. Here there is an example, that is temperature control system in human body. So here you can see whenever the temperature falls or temperature rise, the body used to react accordingly. When the temperature falls, there used to be a shivering in our body, and sweat glands used to close, and the heat is being retained and generates the heat which keeps our body warm, and it comes to the normal body temperature. Whenever the body temperature rises, the sweat glands opens, and we used to get the fluid out, and the fluid has been evaporated and heat has been lost, and we used to come to the normal body temperature. So as I mentioned earlier, it is the perfect intelligent control system. So before entering into the topics, what is system? As I mentioned, working together as a part. So whatever may be the thing, when a combination of parts are being connected and it works together, then it is said to be a system. And when the system is controlled with the help of some machine in order to get the desired value, then it is mentioned to be as control system. Okay. Application of control system, open loop system. We have fan, speed control, heat control in iron box, remote control system, and closed loop air conditioner, cruise control in car, path tracking in satellite and missiles. So we know that all the three things which are shown in closed loop applications used to take place automatically, because in air conditioner, if we are setting a temperature of 17, okay, so the outdoor unit used to start and stop automatically. There is no need of control. So it used to keep the temperature inside the room 17. When there is a drop in the temperature or when there is a rise in the temperature, automatically the outdoor unit used to start or stop the fan and keeps the temperature, maintains the temperature at 17. So it will be having the sensors, it will be having the actuators. So all the parts are being connected, which is said to be a system, and it is being controlled based on the signal which is being received by the sensors. Okay, basic thing: open loop system and closed loop system. Here we have gone through a example of dryer system. Okay, here timer is the controller, heating element is the output, and clothes are the process. Clothes used to be wet when we are putting it in a dryer, so it has to be dried. Okay, but when there is an external disturbance here, the cloth won't be getting dried. So there will be disturbances due to the external effects in an open loop system. So here, as it has been mentioned, there is no feedback mechanism. So the disturbance will not be sensed and there will not be any corrective actions here. And desired performance is not guaranteed because output is not dependent on the input. Now, let's have a look on the closed loop system. Here you can see, as I mentioned earlier, if there is any disturbance, it is being sensed. The output, the actual output we are not getting, which has been sensed here with the help of a sensor, and a signal conditioning unit will be there, which will be changing the signal and it will be given to the error detector here, which will check with the input value, and the error signal will be generated and that manipulated value will be given. Based on that, we will be the heating element will be acting and the clothes will be dried. Okay, so here the output is dependent on the input. So this is said to be the control system because we have a feedback also here. Basic functional elements of a control system. We used to have a reference input, as here it has been mentioned. As I mentioned earlier, we used to have an error signal, that is the output part, and the reference input are being compared and the signal is being given as error signal, which is being given to the controller, where we will be getting the manipulated input. That input will be given to the plant, so automatically we will be getting an desired output here. If there is any change here also, then again the signal will be given and here comparison will be taken place, and error signal will be given to the controller, and we will be getting a manipulated output, and based on that the plant function will be taking place and we will be getting a desired output. Okay, if we are considering a open loop system, this part will not be there, so the differentiated output will not be given to the input. That's the change between the open loop system and a closed loop system. Okay, next, linear and non-linear system. Everyone know about linear and non-linear system. Here just I have taken the graph characteristic of a LVDT. So output varies linearly, that is y equal to mx. Linearly it moves as there is a displacement, there will be a difference in the voltage. It obeys the superposition principle. And when we are seeing about the non-linear system, here a best example is being given. You are having a conical flask and a burette. We know when the liquid which is present in the burette is being added with the liquid which is present in the conical tank, there will not be change linearly. Suddenly a drop will be changing the color of the liquid which is present in the conical flask. So which is a non-linear thing. That is why it is being mentioned as y equal to mx square. So output is unpredictable for a known input, does not obey the superposition theorem. The flight system also tells the same thing. Now we have seen about the linear and a non-linear system. Here linear time invariant system and linear time variant system are shown here. Okay, linear time invariant system does not vary with respect to time, or else a circuit will not be varying with respect to time. The coefficients of the differential equation described in system are constant here. While we are seeing about the linear time variant system, here you can see the missile. Here the mass of the fluid which is present will be varying based on the distance it has been traveling. So there will be change in the mass whenever the distance is been varying. So there is a linear change here, linear time variance system. The system parameters vary with respect to time, and coefficients of the differential equation describing the system are not constant here. By mistake, I have mentioned here as constant. It is not a constant thing. Now let's have a look on stable and unstable system. Based on the diagram itself, you can see which one is the stable system and which one is not stable system. Ball on a hill, which mentions the stable system and the unstable system. Okay. Bounded output for a bounded input. That is said to be the stable system. For an example, I have mentioned what is meant to be the bounded thing. Amplifier with a range of 0 to 5 volt DC, which is the bounded input, having 0 to 10 volt DC bounded output. So whenever there is a variation in 0 to 5, there should be a variation of 0 to 10 only. It should not vary above that. That is meant to be the bounded thing. There will be a range for the input and the output. That is it. If the range is taking place and there is a variation, then we can say that it is bounded input and a bounded output. Then the system is said to be a stable system. Here the graphs have been shown. This we will be seeing in the future classes. Okay, and marginally stable. It can be unstable or it can be stable. That is shown here. An unstable system, we can see here, if we are keeping a ball on the hilltop corner, okay, it may move here or it may move this side. It can't be here because there will be some external disturbances which will be making it to move either direction. That is said to be the unstable system. Okay, for a best example is inverted pendulum. If there is a change in the displacement of the inverted pendulum, the output, that is, it will be moving drastically. That we know that the output of the linear system is unbounded for the bounded input. That is said to be unstable system. You can see here the graph. It should come to the stable part. It should come for a saturation, but the graph is moving drastically. That mentions the system is unstable. And here also you can see if it is a perfect sine wave in the top and the bottom is perfectly there, means then we can say that is marginally stable. It can be stable or not. But here there is a drastic change which mentions that it is unstable. So in this video lecture we have just seen the introduction part, what is said to be open loop system, what is closed loop system, what is linear system, what is non-linear system, linear time invariant system, linear time variance system, and what is meant to be stable system and unstable system. In the upcoming classes, we will be seeing about mechanical system, that is translational system and rotational system. We will be seeing the three different parameters that are present in translational and rotational system. Thank you.